Hello everyone. Today also we are going to see another topic in counters. So previously we have seen um, asynchronous counters, asynchronous up counter and asynchronous down counter. So in this video we are going to see a counter which will be counting both up and also down. Okay. So we will see that what is the logic behind that everything. So as I told you, we are going to design a counter which will be counting up and also down. Both is possible. How it is possible? So in this case, we are taking an example of 3-bit counter. Okay. So to do up counter uh, uh, or down counter. Okay. So we will be having one more extra input called M, which is mode selector. Okay, so which is called a mode selector. So according to the input of em, either the counter will be acting as an up counter or it will be acting as a down counter. So in this case, if m equal to 1, the counter will be a up counter. Okay, if m equal to 0, the counter will be down counter. Okay, so you will be having a little bit changes in the circuit diagram. So what kind of changes will be there? We will be going to see. See, in previous circuits like separately up counter and separately down counter, the output of one flip flop is given as an input to input clock input to the other flip flop. So here also we are going to do the same thing, but slight modifications are there. Okay, we will see that. So just for recap purpose, so we see have seen this. This is our asynchronous up counter separately. It will do only the incrementation. This is our down counter. There is no much difference in up counter and down counter. Only difference is in up counter, the outputs will be taken from q itself. In down counter, the output will be taken from q bar, which we have already seen previously. So when we integrating both the things, what is happening means, see, this is our circuit. Okay, don't worry about it is so much complex, it's very easy circuit. Okay, so we are having three flip-flops, right? We are having three flip-flops. This is for 3-bit. Okay, three flip-flop. So input is always, see, input for counters, input should be always one. So x is our input, so x input has been given to j and k, j and k as same as previous one. Clock is also given as same as previous one. Okay, so clock has been given like this and it will be working. Okay, so in case of up counter, so what is happening in case of up down counter, we will be having an extra input which is am. I told you this is our mode selector. Okay, this is our mode selector. So what is happening here, and one more thing we are included was two AND gates has been included, and that output of two AND gate has been given to OR gate, and that OR gate output is given as a negative edge triggered clock for the next flip flop. Okay, if you are having three flip flops, you will be having two intermediate circuits like this. Okay, so you can see here two AND gates, OR gate, two AND gates, OR gates. So the output of AND gate is given to OR gate. The output of OR gate is given to NOT gate for negative edge triggering, and it has been given to a clock pulse. Okay, so then what is the input of AND gate? Say this is AND gate 1 and this is AND gate 2. So AND gate 1 will be having an input from M, directly from M, and another input is from Q. You can see here another input is from Q. So this is for AND gate 1. If I go to AND gate 2, so the input is taken from M and it has been inverted here. Okay, it has been inverted here. So this inverted one has been given as an input to AND gate 2, and Q bar is given as an AND gate, another input as a AND gate 2. See, Q bar for the second AND gate, and from M the inverted output, that means complemented M output has been given here. Okay, so accordingly it will work. Okay, so that means whenever m equal to whenever m equal to 1, okay, whenever m equal to 1, this will be acting as a circuit and accordingly it will work. So this will be the up counter. Okay, when m equal to 0, this part becomes inactive. That means 0 will come here. So 0 of 0, anything is 0. So we will be having here 0. Okay. But in this case, you will be getting output here. Okay. That means 1 will be here. This will be active. So this will be acting as a down counter. Okay. So according to the m value or according to the m input, the up counter and down counter performance will be happening. The output is taken for both the cases from Q only. You can see the output is taken from Q only for both the cases. Okay. So in previously down counter we have taken output from Q bar, but in this case you can take output from Q itself because the input is changing. Okay. So the clock inputs are changing, so you will be getting like that. Okay. So we will see the working of this circuit and we will come to know how it works. So this is the circuit for our working purpose I have created here. So with respective of waveform generator or graph, step graph, okay, clock pulse wave diagram. So if I start simulating, you can see right now x is also 0, m is also 0. There is no counting operation going on. Now what I'm doing was I'm giving m equal to 1. But still counting is not started because x value is still 0. So I'm giving right now x value is 1. If it is 1, what it should do? It should be a up counter. So initially it is 0 0 0. You can see that Q0, Q1, Q2 is 0 0 0. So now I'm giving 1 here. So what happens here? You can see, so 0 0 0 0 0 1 0 1 0 0 1 1 0 1. Likewise, you are getting right all the things. Right now it is incrementing. Okay. So if I make it to 0, it will start decrementing. When I make m, it will start decrementing. We will see the tabulation so that you can understand easily. Okay, so this is the working of up down counter. Okay, according to the principle of this one, you have to make it. Okay, so we have seen the working principle. Now we will see the truth table. So truth table looks like this only. So when m equal to 1 and x equal to 1, you will be having a counting of starting from 0 0 0 0 0 1 up to 1 1 1. Still, if 1 is maintained means it will go back to 0 0 0 0 0 1. It will be going like this only. Okay, when m becomes 0, counting will start from decrementation process from where it has become. For example, while incrementation process, you have changed the value of 1 equal to 0 at the fifth position means it will start decrementing from fifth only 5 4 3 2 1 like that it will go. So actually it will make decrementation process. To explaining that I have made like this. So whenever 0 0 0 is there, that means whenever m becomes 0, it will start decrementing up to 0. If still 0 is maintained means it again goes to 1 1 1 1 and then 6 5 4 3 2 1. Likewise, it will start decrementing. So this is the working of asynchronous up down counter. Okay. Thank you. We will see in the next topic.